into this. All right. Here we go. On the edge of polarity. Relax. That's good. All right. Today we're talking about systems of equations. Systems of equations, just more than one function. And where they intersect is going to be what's called the solution. This is, I want to start with this because I can show you how this actually relates. We have one function here that represents cost, and we're like selling refrigerators or something. Right? We have one that represents our revenue. Revenue is money that you earn from selling stuff. The cost is how much it costs to make the item. Right? So you can see that if your cost is greater than, the part of the graph where the cost is greater than where the revenue is, that means it's costing more to produce the item than you're able to sell it for. Right? So this is really important. If anyone's going to do business or advising or accounting or finance, you're going to use these kind of graphs all the time, because you don't have to start a business saying, I'm going to be successful because I'm going to work as hard as I can. That is not a business plan. A business plan looks at the feasibility of selling the item that you're making and if you can actually make a profit. And there's some business ventures you just shouldn't do because you can't work hard enough to even do well. You don't want to get burnt out like working on a project for 2 years and then realize you couldn't have made a living, right? So I have a friend who, actually it's my good friend's girlfriend, who tried to start a knitting company, a knitting business. She made these really cool figurines, like these little stuffed animals, like all different kinds of animals. They're really good. But why is that potentially a bad business to start? What's an issue with knitting? Yeah.
A lot of people don't like it.
Some people don't like knitting. What else, Wazine?
Time consuming?
Time consuming. So to make a little stuffed animal that was this big, like a dinosaur, guess how long it would take?
I'll do like 1 week.
8 to 10 hours. Right? So in order for her to make money on this dinosaur and be able to pay for the cost of the materials and everything, she'd have to sell this dinosaur for like $150. And that's only going to be, bought by somebody that, if it's like an art piece or somebody who's really wealthy. So I remember talking to my friend Joel, and I was like, I can work this out. I can work out the math to see how many she needs to sell based on her costs versus revenue. Because this is the break-even point. Our solution in this case, where they meet, is the break-even. You have to sell more than 10 refrigerators in order to start making profit. Where for her, maybe it would have been, you have to sell more than, 100 stuffed animals to make a profit. TK?
It's pretty cool because, my family has a clothing business.
Okay.
And so we go pretty much every weekend to like different events and stuff.
Okay.
And so you have to pay for like the cost of the food to be there to sell. And then gas and all
Right.
of you have to take all those into account. So my mom will tell us pretty much like, okay guys, we broke even, so now we're making profit.
She knows the
It's
point.
pretty cool, yeah.
She knows the threshold.
Mhm.
Great. So if you're going to run a business or do anything, you have to learn how this works or have like a really good grip on what your expenses are and your revenue, right? Because you don't want to just ever be in a place in your life where you're like, all I have to do is work as hard as I can. If that's the only thing that is part of your plan, you got to look more, because you're going to have to work as hard as you can anyway.
Yeah.
Don't work as hard as you can if your venture isn't going to work out. Okay? Not every opportunity is worth taking. Right? No.
So the break-even point means that you've sold how much you've spent?
That means that at this point, after I sell 10, the money that I had to pay for the item to sell and how much I paid for it, now it's 0. Now it's even. I broke even. I didn't lose any money, but I didn't gain any money. You got to gain money to, well above what your profit margin is here, in order to have like a living, where you can have, enough to have, health insurance and the things that you will need to sustain, right? Not just health insurance, food, that kind of stuff, I guess. Or if you have kids, you got to think about their health. So people have the American dream of like owning a small business. You got to think about this stuff too. It's not as fun. It's not as like romantic as like I have my own business. Yeah, you have your own business, but you never go on a vacation for 5 years and you work 70 hours a week, so congratulations. You know what I mean? Like, make sure your business venture is worthwhile so you're not wasting your part of your life. As we get over here, you can see also the profit increases. We get more and more profit as we go up. So this is actually a pretty good business model, because they only have to sell 10 units in order to break even. And you can see as we sell more and more units, we're going to increase our revenue. Okay. Does this make sense why it's useful? Okay. And it's not too hard to create these equations. I think we get into that actually next semester when we hit this again. But I wanted to bring this up. I'm going to close this now. We'll come back to it. And I'll pause the video here because I'm going to give you a moment to copy this down. So I'll give you just, and we're back. Okay, so we're talking about systems of equations. I just abbreviated SOE. So the solutions for a system of equations, the solutions is where the function intersects. Okay, so if you were thinking about, you know, here's Stockton, right? Here's Fruit Ridge. Where do they intersect? It's an obvious question. It's kind of rhetorical. Where do they intersect?
At Stockton and Fruit.
Yeah, right there. Where would I have to put a cone in order to be right in that intersection? Where would the cone have to be? Right in the middle, right? So if you were driving on Fruit Ridge or Stockton, you could hit it on either direction. You know, you wouldn't want to, but you might hit it. So let me just make this easier to see. There we go. Okay, so the key is the solution for a system of equations is where the two functions meet, where they intersect. And the key idea to this is that cone is on Fruit Ridge. The cone is also on Stockton, right? So if I look at them independently, if I have a location for the cone and I look at them independently and say, well, is the cone on Fruit Ridge? Yes, it's on Fruit Ridge, right? The point that we're going to be looking at with our coordinates, that point has to be a part of Fruit Ridge and Stockton. Otherwise, there's no way for them to meet. We're going to have to like double prove that. Okay, we're going to prove it with graphing, and with our two methods, we're going to see. It's going to come pretty quick because we're going to do synthetic substitution. So if there's no solutions at all, no solutions, they don't touch. Does power in ever touch Stockton? Power in Stockton? No, because they're kind of like this, right? Parallel-ish. Okay. So when there's no solutions, it's just because they don't touch. That makes sense, right? One solution touching once. Multiple solutions, we're gonna have an intersection 3 times or more. How can we get infinite solutions? How does that happen? They're all touching, and so who can give me like a situation where that happens? It's kind of hard. Give me a situation. Yeah.
It's the same line.
It could be the same line. Good. Has anybody ever been to Chicago? Yeah. Okay. What do they have in Chicago? What kind of subway do they have?
I didn't think
Remember? You wouldn't, because it's an elevated train. So in Chicago, if you're on like Shoreline or whatever, you wouldn't be on Shoreline, but the trains follow and they go right above the roads in some areas. You seen that? So it's in like Brooklyn too. They have that a little bit. In New York they have it. But I'd say that if here's the road and here's the train, they have intersections everywhere. They're not quite touching, but if we're looking down on it at a map, you can see that it's infinite solutions because it's the same thing. Okay. So here are the different situations we're going to deal with. Okay. These would be labeled as points. So I would label this as my x and my y there. Here's my x and my y. Here's my x and my y. It's pretty easy to find the points. Our solutions are going to be points. That's key. Maybe put that. Solutions. We're talking about a point, an x and a y, because we're seeing where those intersections are. If you just say it's this for x but not for y, it doesn't tell me where it is at all. Okay. So here's the situation we're going to face. We're going to have different functions, and we're going to solve using 2 different methods. One is going to be graph, and then we have to test the solution. We're going to use Desmos for that. The other one is to set the functions equal to each other, and we go ahead and solve. So let's look at Desmos first, because, I mean, who doesn't love Desmos? Not you?
Desmos is great.
Desmos is great. Desmos. We can do a Desmos chant at the end. Say what? Okay, here we go. Listen up. Here are this is my Desmos function. It is the same one you had for method 1. It's just hidden. It's the same one that's here for method 1. We have two functions here, negative 2x plus 1 and x to the third plus 2x squared plus 5. How many solutions do we have in this situation?
What?
One solution, right? One solution. One intersection point. Using Desmos just to check and double check you know this. How do I find out what that point is? What am I going to do? Click on that point. It brings up the ordered pair. I know that's my solution. This is my solution. It would be way too easy if that's all we had to do for the classwork. You're like, done. That would be really boring. I don't want you to be bored. So I've come up with our task of testing it. Here's what we're going to do. What we're going to do is, I know that for this situation, here is my solution. We have y is equal to negative 2x plus 1, and we have the y is equal to x to the third plus 2x squared plus 5. So with this, if I'm looking at this, just make sure it's keyed up right. All right, looking at this solution, here's my x and my y, right? Here's my x and my y. I want to use synthetic substitution to see if this is a solution for this road and this is a solution for this road. Again, the cone has to be on both of the roads, and at the intersection, it is on both of the roads. It's just where they meet. So are there any terms missing here? If I'm going to do synthetic substitution, I got to make sure my terms are there.
No.
X to the first, constant, right? So what I'm going to do is, I'm going to put negative 2, and put 1. And what I'm checking is, when I substitute in negative 2, what do I end up with for my y? If I just gave you this expression, I said, I want you to do this to figure out what happens when we substitute in negative 2, right? You're finding a solution there, and really what we're finding is the solution for y. So let's do it. Drop it, multiply it, answer, 5. Does 5 match what we had up here? Yes. So I know that this is a big check mark. I could do better. Some more of that. Easy? Is that pretty quick? Pretty easy, right? Do that. How about over here? Are there any terms missing?
Yes.
What's missing?
X, just regular X.
Third, second, first. The x to the first is gone. 1, 2, 0, 5. Everyone okay with setting this up? We've done this a lot. I feel like you guys are pretty confident about it. Okay. So what am I going to put in here to check if this solution works for this one too?
Negative 2.
Negative 2, everyone agree? Okay. Negative 2, what number should come out on this side in order for me to know it's a solution?
5.
I wouldn't even put 5 there. If it's right, then it's a check mark. We're good. All right, drop it. Multiply it. Drop it. Multiply it. Drop it. Multiply it. 5. Is that a solution?
Yeah.
Check. End of problem. It's going to be quick. It's going to be really quick. Any questions on that one? I'm only going to show one example for that unless you need more. All this work I did, this is the test. We're testing if this solution that we found from the graph works for this function and for this function. When I substitute in negative 2, which is what synthetic substitution does, it gives me my answer, which in this case would be my y value. So I know that if I start with negative 2 and get 5, and it matches that, good to go. Start with negative 2, get 5, good to go. That's all we need to do. It's a double check.
Where did you get the negative 2 and 5 from? Or is it given to you?
That is from the graph. So you're going to use Desmos for it, so that's a good reminder. You're going to use Desmos, you'll put in the two functions, you'll find where they meet, and then we're going to go and do the double check. That's the process. So thanks for helping me reiterate this. Okay. So let's go ahead and bring it back. Close up Desmos for a sec. Let's look at this one. All right, next. Next. We have our next process. I don't know why I'm moving this so much. Sorry to those at home. You're getting all sick. All right, the next step. This is our next step here. The other method you can do, which you'll have to do for some of them, right, is to set the functions equal to each other and solve for the solution. Now think about this. When f of x equals g of x, right, that's the same idea as when Stockton, the location of Stockton equals Fruitridge. Where do I find where Stockton equals Fruitridge? What pavement is on the road where Stockton equals Fruitridge? The intersection of Stockton and Fruitridge, right? So essentially what I'm saying is, with these two functions, when f of x equals g of x, that's that point they have in common or points they have in common. Okay. So I'm going to go and take f of x, x squared plus 2x plus 1, make it equal to the other. And I need folks to help me out with this. I forgot how to do algebra. What should I do? Should we move everything to the left or the right? And tell me why. Should I try to get everything to the left?
Yeah.
Why?
Makes it easier.
Makes sense? Notice. Because we're going to keep it positive with algebra and whatever we're doing. All right. Gone, gone. Now I have 2x plus 1 is equal to negative 3x minus 9. You see, if I'm moving everything to the left, this negative 3x becomes positive. It's going to be combined with that 2x. So plus 3x. Plus 3x. Gone. 5x plus 1 is equal to negative 9. Next step. Minus 1 minus 1. 5x is equal to negative 10. Next.
Divide both sides by 5.
X is negative 2. Okay, but what do we need as our answer? We don't just need x is negative 2. That's not that helpful. What else do I need to find? I know that 2 is the first part of that answer. And how do we find what the y value is? Let's see. What do you think we have to do to find what the y value is? Stop following. Plug in the x. Let's use synthetic substitution to make it easy for us. What do you think? I'm going to plug in 2. And which one of these looks easier to plug in? F of x or g of x? Top one, f of x. Are there any terms missing there? No? So we're going to go 1, 2, 1. Math?
So are we doing 2 and not negative 2?
That's correct. Whatever values are here, everything is completely matching. There's no anomalies where we're switching the sign like we did last week. That's correct. The reason being is, at this point, what we've solved for... I was looking here. You were looking here and you're just wondering how I changed that.
Yeah.
Sorry.
I got you.
You do. You do got me. And you just Harvard for
Whoa.
catching my mistake. Woo! Yep.
Oh.
Did you just spike it back at me?
Yeah. Here you go. Yay.
Alright, it's always good to catch my mistakes because I appreciate it. And you starters.
Yes, get it
It's
started.
all about the
Catching
incentive.
mistakes.
Alright, what do we have to do now? We're plugging in negative 2. Drop the 1. Multiply. 0, 0, 1. Done. Again, what did I do? I made them equal to each other. I solved for my x. I used synthetic substitution to find what my y value is. And you could choose to plug it into either of these because you know you're talking about the intersection. You're talking about the intersection. Okay. I think we need to see another one like this. Maybe like a step harder. Okay. Let's do one. Let's do one over here because I can erase the board now. All right, I want everyone to do this one because it has a little bit of a more challenge to it. You're going to see a problem like this. So let's go f of x, let's call that x to the third. We'll go, no. Let's make it 3x to the Second, minus 15 is equal to negative x squared plus 1. Excuse me. This is my g of x. I'm going to make them equal, but I don't want to. Negative x squared plus 1. Here's my two functions in my system. Okay. I want you to do the first step there. What's the first step?
Separate. If you want to do that way with the word.
I'd like for you to do method 2.
Oh, okay.
So let's follow, what does it say? Set the functions what?
Equal to each other.
Let's do it. Set them equal to each other. See what happens when you go to solve this. This is also a review of a skill that is easy to forget. So work on it on your own, or we can knock it out together. What do you think? On your own? Start? Okay, I'll let you get a head start. I'm going to start to do some of the steps in case you're confused. I'm going to add this x squared to both sides because that gives me x to the 4x squared. It keeps it positive. Then I'm at this step. What's next, Weezy? Let's add 15. 4x squared is equal to 16. Okay. What's your option? What's next?
Then you square root both sides.
Ooh. Let's do something else, simplify it a little more before we square root it. Eva. Divide by 4. I like where you're going with those options. So I'm just going to rewrite it down here because I want to show this process a little better. So now what should we do?
Now you square root both sides.
Let's do it. So we square root both sides. On the left side, it cancels out. But my question to you is, this is the key. This is why I did this. This is the key. It's the key. What is the square root of 4? In essence, what times what gives me 4?
2.
What else? Nope. Has to be the same number. It's just 2. Is it?
Isn't it?
What else is it?
Negative.
Oh.
Negative 2 times negative 2. You guys remember that? Is that true?
Yes.
Negative 2 squared is 4 as well, right?
Yes.
So watch what I have to put. I want you to do this. Plus or minus 2. Now the situation is now we have 2 of our solutions coming into view. We have a positive 2 and a negative 2. And what's our slick method of figuring out what our y values are? Plug it in using synthetic, right? Let's use synthetic. Substitution 3, 0, negative 15 because there's a missing x term here.
Yes.
So I set it up, drop it, multiply it. Get it in there to negative 3, negative 3. That's one solution, done. Then we're going to do negative 2. Same coefficients. Drop it, multiply. Keep going. Multiply 12. It's okay. It's okay because they're both down 3 levels. The y value is negative 3 for both of them, but the x values are different. So really, essentially what we have here with these 2 points that are solutions, we have both of them are at negative 3 for y, but one's over here at negative 2, one's over here at positive 2. So you see it's going to be a little bit different. You agree? Okay, so it's okay if the y is the same for both of them. If it's exactly the same point, then you might have just done the problem twice, exactly the same. Okay. So it's election day. Should we do a special kind of outro? Go vote. All right. How about 1, 2, 3, go vote? 1, 2, 3, vote. Wait, what'd you say?
Or register.
Oh, it's too late.
Let's go 17.
That's true. I want people to vote.
I registered.
How about 1, 2, 3, register and vote?
Okay, yes.
1, 2, 3, register and vote. 1, 2, 3.
Register and vote!
Do it.